curve tracer is basically a number of the SMUs connected to the relay matrix and number of pins on the interface and the software that can operate all these SMUs in parallel to give you different configuration of the measurements and at the same time be able to do measurements for multiple pins on a device. For the regular SMU, you can measure like a diode or resistor. If you combine 2 or 3 SMUs, you can measure transistor characteristic, but to measure the characteristics for the entire integrated circuit, it becomes very complicated. For example, National Instruments, you have to have several modules in the chassis, including SMUs and separate relay matrices and connect everything and then have dedicated software. In our case, we basically combine everything together in one chassis. That's basically how it works. And let me show you in a software how it functions. Okay. So I have a software here. That's for regular curve tracer. And I have a device right now connected to the tester. And this device has only like 13 pins. Here on the right side, I can define the parameters for the test, like voltage range, number of steps, all the pins that I want to measure. And also here, I can define the conditions for the test. So right now I have selected where we have one pin from this device connected to ground, because you don't have like a dedicated ground pins or power pins. Every pin can be either connected to ground or to power supply, or can be connected to the SMU. So it gives you complete flexibility on your setup. When I start the test, it goes pin by pin and takes the characteristics. And after it's done, it will plot it on a screen like this here, right? So we have a number of characteristics, and every of those characteristics is a separate pin for the device. And this you can do with a regular SMU, but it needs number of instruments combined together and sometimes like a custom software, or you have to do everything by hand. In case of automatic curve tracer, all you have to do is define those pins, define your type of test, parameters, and hit the start button. And you are done. You see, it took 10 seconds to get the measurements for 13 pins. This characteristic is with just one pin, which is ground for the device, connected to ground, and all other pins are disconnected. If I change the mode, this is very hard to do with externals. I have the power pin here 3, when I have one pin connected to 5 volts, and this will be pin here 16, which is power pin. And when I just, without changing anything, hit the start button, you see we run the characteristic again, but before we change the condition, you will see the characteristic is completely different. Yep. It's completely different characteristic. I have set limit to 2 milliamps, so you see that it cuts off at 2 milliamps on both sides. And you see that, for example, this one is pin CP, which is slightly different from other pins. Those pins are just master reset and stuff like this. This pin is output pin. So each of those pins has slightly different characteristic. Now, if I have a reference plot, I can actually load this golden device characteristic. And right now, you see some of the pins here show the fail, some show the pass. And right now you see only one plot on the screen. And the green line is a reference, ideal plot. This beige one is just what we measured. And you see those plots are different. That's why this pin failed. If the plots are identical, like this, for example, 27, you see both plots are overlapping, and the pin is passing. I can actually change the display mode from this characteristic to reference plot. And then if I change the deviation alone, I can see on the screen the area that the actual plot must fit in. So we can change how much deviation we allow for a device.
Okay, got
In
it.
addition
Okay.
to those tests, we have tests like a continuity test when you can, like for a regular pin, you can test diodes in the ESD circuit, but here you can do both the upper side diode and the lower side diode. In most cases, only one diode is tested. Here you have the option to do both, and the test will take only hundreds of milliseconds to run. Or another test is pin-to-pin connect, when you specify the pins that needs to be connected together and then the maximum resistance between those two pins. And this can be used for devices when you have multiple pins connected to the same power rail. So you can make sure that all the pins are connected together. The same when you have multiple ground pins, you can measure if all those pins are connected together, or you have like analog switches or anything like this, so you can measure the resistance between pins where those switches are closed. When you have all these tests defined here, you can change the test modes, you can enable or disable this golden pin, you can define your power groups and stuff like this. And you also can go to batch testing. And batch testing is basically, I can just add number of tests on the screen, basically select the file, like this file here, for example, define the test, continue, and it adds to the list, like a ATX in our system, using the same but change to the curve trace, and so on and so on. And then save this file for the future reference. And instead of running everything from this interactive mode, you can just hit the run button to execute all these tests one by one, and the results will be pass or fail. I can even start it here. Of course, I don't have defined conditions for the continuity. So it says failed, the other says in progress, and it will give us in a few seconds some results. And all the results are actually stored into the text file. Okay, this one passed because it doesn't have defined the curve trace characteristic. And if I open the log file, you see the log file is basically all the text that you can analyze. You can put it in the analytical tool like Excel or some dedicated tools from Mentor Graphics and process it for the future reference. Or you can use just those pass fail status here to define if the device is good or bad.
Yeah, got it. Yep.
One of the applications is the failure analysis. When you have your golden device and you have a device that it's failing, so you can take the characteristic for all the pins and locate the fail very easy, very quickly. But also you can test it also for counterfeit.
Yeah,
And
I see.
how you can use it for counterfeit. Let's talk about methods for counterfeit integrated circuits. The basic one, but it still is no die in a package. And we are ourselves victim from it. We bought the 2 trays of our NEC memories from a vendor, and it turned out all the chips were empty. There were no dies.
Yep.
So
No, I've seen it.
yeah. So curve tracer and the continuity test immediately will give you the result. The pins are open. There is no die in a package instantly. Same when you have the wrong die. So it's basically the right package. There is a die, but the die does not correspond to the data sheet. You can detect it by either continuity, or in cases when you have multiple power pins, multiple ground pins, measuring pin-to-pin resistance, you immediately have the answer, hey, those pins should be connected, but they are not connected. There is something wrong with the part, or this is the wrong part. Or when you take the IV characteristic for those pins, you remember when I switch back to these curves.
Yes.
Let me switch off. I need to go to golden pin setup and switch this off so I can make all the pins visible. You see, every
Yep.
pin has a different characteristic. And if you have a different device, those characteristics will be different. And comparing
Yeah.
it to the golden characteristic, you immediately say, hey, that's not the correct path. So you can detect it. Slightly different when you have the both pulls. So this is the correct part, but it's not the new part.
Yeah.
Now we're saying it's possible because in some cases the difference will be so small that you cannot detect it. But it means that this device is so close to the good device that you can probably use it and you will not see the difference. But over time, especially when you have multiple heat cycles, the characteristic for those pins will shift and then will be outside the allowed variation. And again, some pins will fail, so you can
Yeah.
detect it. And also sometimes the chips has older generations, so like a revision for the die. And there are differences between different revisions of the dies with a slightly different characteristics. And then you can actually detect that, okay, this is older revision and the marking says this is the latest revision, and you know that's something wrong.
Yeah.
Another similar case, when you have a real part, it can be old, it can be new, but it's damaged. Also, Cave
Yeah.
Tracer will tell you, for example, when you measure the current on the power pin, that the IDD after power reset is higher than expected, and it will fail the test. So
Yeah.
you can detect this. Another kind of knockoff parts is that you have the parts that are functionally identical to the original part, but they are manufactured with a lesser process. So it's basically like a knockoff part.
Yeah.
And by measuring the pin characteristics, you can tell that it was basically manufactured with a different process. So it's not original part.
Yeah.
And last two types of counterfeit products is speed up marking. And this you cannot actually detect. It's like they will take the processor, which is 3 gigahertz processor, and they will mark it 3.5 gigahertz processor,
Yeah.
and then sell it with a higher price. This
Yeah.
we cannot detect. For this, you need an actual functional tester and run the
Mhm.
AC test for this. And also spec up marking, like you buy the commercial product, which is spec, let's say 0 degrees Celsius to 80 degrees Celsius or 70 degrees
Yeah.
Celsius,
Yeah.
and they sell it as a industrial from -40 to plus 125.
Yeah.
Again, this we cannot
No,
detect.
not okay.
You can detect it only with a functional tester and full setup. But the
Yeah.
cost for this will be between $3 and $5 per chip if you run like 1,000 chips batch.
Yeah, definitely. Yeah, it's going to be expensive. Yeah.
Yeah. So what we offer is reasonable price because this curve tracer is not expensive and it's easy, as you saw. It is very easy to set up and it's very easy to run, and it will cover like 80% of those counterfeit products. And those that
Okay.
when they speed up marking or spec up marking, those are those expensive parts already manufactured. They implement methods to prevent it, like ID inside the chip or DNA marking. You know DNA marking, right? These can be detected by visual inspection or
Yeah.
ultrasonic this reflection maps and stuff like this,
Yeah.
right?
Yeah.
Again,
Ultrasonic.
those are very expensive, time consuming, but if you have expensive part, you are willing to pay extra
Correct. Yeah.
for these cheaper parts. Probably that gives you quite good confidence that what you buy is a good part. So this is like extra fast, extra.
Yeah, no, because most labs here do EMS shops have a CSAM X-ray, all that, just to verify that the dye's there. That's all they do.
Yeah.
But
X-ray is
yeah,
another good way to
and
do
then
it, and even like a image comparison where they
yeah,
look at the bonding and stuff like this. Yes.
correct. Yeah, but then you need an expert engineer, and you need very expensive equipment. So
Yes.
again, yeah,
One of the benefits of using this curve tracer is that, especially in this batch mode, is
yeah,
once you have everything set up, you can just ask technician to do the testing for thousands of those chips because they
yeah,
don't need to have any specific knowledge. All they have to do is just put a device in a socket, hit the start button, and if all is green, say, okay, this part is good. If it's red, discard it.
yes. And what price point are we marketing this tool at right now?
Let me see. The latest prices we
Oh,
had.
sorry, then jump ahead. I jumped ahead.
So
Sorry.
the yeah.
Yeah,
So the chassis, the mainframe for the smallest one was like a 10K. The same for 8 boards. 8 boards is up to 1,000 channels, also 10K. And then the big one for 2,000 channels is like a 40K. And then the board, I believe, was like 4,500 per board, which is 128 channels basically. And you have 3 different packages available. The small one on the left is up to 384 channels and it's just a desktop solution. You can have either like a load board with a dartboard, or you can have like a test socket in front. The one in the center is up to 1,000 pins, and it means 8 boards in the system. And the one
yeah.
on the right is a regular chassis, 2,000 pins. So you can
Okay, got
even
it.
test in devices in parallel, like 4, 8 devices at the same time to reduce time and cost.
Okay, good.
And each board comes with a 4 SMUs. So if you have 3 boards, you have 12 SMUs in the system.
And
This one is this universal test socket, and with this test socket, you can use those readily available adapters for different
oh yeah, then just
footprints.
plug in. Okay.
Yeah, you just plug it in
Yeah.
and then tell the software which pin is connected to which channel,
Mhm.
and that's it.
Okay, good.
So there is no functional testing, so you don't have to provide test patterns, only the characteristic, and you define the voltage range and the resolution, and that's it. Even if you have a good known device, you can measure it and store it as your golden device, and it will store individual characteristic for every single pin. So you have, when you have like 100 pin device, you have 100 characteristics, one per each pin. And then when you
Okay.
compare your device on the test, you compare it to this golden device, and it's compared pin by pin. So you can ideally verify every single chip if it's within the spec.
Okay, got it. Okay, it's very good.
And of course, for more advanced things, users don't necessarily have to use this user interface that we provide. Everything, all the functionality is in a DLL, so they can just load this DLL and use this functionality and integrate this curve tracer with another instruments for test automation. Like they have a handler to move devices basically into test sockets and out of the test socket. And then with the test result, they can automatically bin those devices and separate them in a good and bad bin, basically.
It's good. And the
Okay.
price point is good. Yeah, so sorry,
Yeah.
carry on.
I give you like a reference. So Keysight, they have SMU, which is 3 channel SMU, but no relay matrix, just 3 SMUs in one package and then display. So the price point is $90,000 for this device.
Okay.
So for the fraction of this, you have 4 SMUs plus relay matrix, and the software and the computer and everything. And it's like probably like under 40K. And then
Yes.
if you need more channels, because right now it's 128 channels, if you need more, then 4500 is another 128 channels and additional 4 SMUs.
Yeah, got it. Yeah.
Customer can start with very basic and then expand easily because it's just plug and play. All you need to do is to run the calibration, which is automatic, of course, and that's it.
Okay, good.
They can have like 1,000 pins system. Yeah, and you
Okay, that's
can
good.
see also here for everything here is like a configurable. Like you
Yeah.
have those things if you want to hide some columns, like for example, pin name, you can do it. The
Mm.
software will remember these settings. Also, the plot area, everything is programmable. All the colors, ranges, and stuff like this is programmable. And also, all these windows on the screen, when you start the software, it will open all the screens that has been already opened and place them on the same position on the screen. So you basically pick up when you left. You don't have to reopen the same windows over and over. We may, for the for the counterfeit detection, we may add something to the software to make it even more intuitive from what you have here, but that's up to the user, actually.
Okay. No, it looks very good. It's a lot more than I was expecting.
No, that's good.
Yeah, that's good.
Mhm. And
The
again,
price,
the price point is where
yeah,
people can, even the smaller labs can afford it.
Yeah, especially the smallest one, they don't need a card for it because it's a size like 55 centimeters wide and 50 centimeters deep and
Yeah.
15 centimeters tall. So you can
Yeah.
put it on the desk and you can put your monitor on top of it, and it doesn't take up much space.